Today, we have our second installment of our educational product, Physical Physics. We are Team 13, Kit 25. This is Joshua Waiter and Simon Shee, and I am Samuel Holt. So previously, in Design Phase 1, or DP1, we began the development of a BRG educational product targeted towards 9th grade students enrolled in physics. After performing customer surveys, we generated our customer needs and then built our target specifications. We also created a Gantt chart to help us with our planning and started our initial economic analysis. In DP2, we refined our Gantt chart. We conducted an intellectual property search. We performed product decomposition, as well as concept generation, concept selection, and concept testing. Finally, we performed failure mode effective analysis, or FMEA, as well as performing a secondary economic analysis. So the goal of our intellectual property search was to, one, gather ideas from existing products that we could incorporate into our design, and secondly, to avoid several ideas in order to make sure we are not infringing on anybody's intellectual property. So we searched a total of 5 patents in order to generate ideas and also look for patent infringement. So one of our ideas was multiplayer interaction that we could incorporate into our design. Secondly, we considered introducing a scoring system into our product. And finally, we think it might be important to design our product for special needs children. From our patent search, we wanted to avoid 2 main things. One was a corkscrew elevator, shown here. This unique design, I believe that we could run into some issues if we used. Secondly, we wanted to avoid another unique bucket design not featured here that we also should avoid if we want to ensure the legality of our product. Josh will now talk about product decomposition.
Thank you very much, Sam. As Sam mentioned, we chose to decompose our product in order to analyze it on multiple levels. The first level we analyzed it on was the overall system level. At this, we realized that the BRG would have to receive energy and material and result or produce material at the same velocity at which it entered, the material namely being a ping pong ball. We then broke our overall BRG down into multiple subsystems, namely the entrance and exit ramps, the 3 obstacles, and the motor that would provide energy into the system. We determined that we would need a motor to add energy into the system due to the fact that we knew energy would be lost due to friction, as well as to lift the ball to the required 24 inches. We determined that the obstacles should be placed in series so that students would be able to spend the majority of their focus on each one individually, thereby learning more. We then completed an economic analysis to ensure that our product would be financially viable. We determined that we would need to take out approximately a $300,000 loan throughout the course of the first 1.5 years. The majority of our expenditure during the first year went into paying the salaries of personnel who would be doing the design of the product. The production begins in year 1, quarter 4, with sales then occurring during this time as the product is produced, the revenue then being placed at the end of quarter 4. We determined that we would be able to pay back the $300,000 loan by the end of the 3rd year with a 15% interest rate. We believe that this is highly competitive both against external products as well as products created by various other design teams within VTEPs. Simon will now talk about how we chose our different concepts as well as the failure mode effect analysis.
Thank you, Josh. For concept generation part, our team generated 5 possible solutions based on the sub-function for each sub-problem. Then our team is able to compare the possible solution and to see the benefit of each ideas. Also, our team built several selection criteria, like the product should be easy to use, the assembling time should be short. As you see in the figure, in our solution 1, the ping pong ball goes into the BRG, and rising platform drive-by model rise the ball for 24 inches height and deliver it into inclined ramp, and finally the ball will jump onto a scaler. So the result shows the solution 1 has the highest score in concept scoring, and that's why we choose solution 1 as our final solution. Then 16 ninth grade students and their physics teachers were asked to take our concept testing interviews. The result shows 32% of the students would probably or definitely encourage their instructor to purchase our product, and this means our current ideas can offer an interesting product to the customer. When checking the failure mode and the effects of the design, our team find several possible failures that our first obstacle, which is the inclined ramp, could experience. The result shows the track connection, which means the connection between the truck and the next obstacle have 100 for the RPN number, and based on the severity, occurrence, and the detection number. And this means the truck connection can be the serious problem in our design. So, as shown in the figure, the rough truck connection between two obstacles cannot deliver the ball. So our team will probably do some pre-evaluation before the final design is presented. And now Sam is going to make a summary.
Thank you. So in DP2, we conducted an intellectual property search. We decomposed the problem into subfunctions. We created and then selected a solution, as well as performed testing. We did failure mode effect analysis, and we worked on our economic analysis. In the future, in DP3, we hope to fine-tune the design for manufacturing, conduct prototyping, and finally end with a really great economic analysis. Thank you for listening.